Hello, you're welcome to the Chemistry Explained series, part 5. Today we're looking at the history of chemistry. Today we embark on an incredible journey through time. We want to unravel the story of chemistry from its mystical past to the powerful science it is today. You can't imagine that there was a time science was shrouded in mystery, when people believed that gold could be created from lead and that an Elysium of life could grant immortality. This was the world of alchemy, the birthplace of what we now call chemistry. We're going to look at the 5 different stages that chemistry has undergone before we came to this level. Number 1, the ancient chemistry. That's the pre-alchemy period, the ancient time to about 300 AD. Ancient civilizations, the early civilizations, especially in the Oriental world, the eastern part of the world, we're talking of the Egyptians, the Greeks, the Chinese, and the Indians. They practice rudimentary chemistry through medicine, through dyeing, and through metallurgy. In fact, a Greek philosopher called Democritus, he was the one that proposed the idea of atoms. The word atomos is a Greek word meaning uncuttable, representing what that letter said about indivisible. So uncuttable is indivisible, very tiny. So it was a Greek scientist that proposed that. The second stage is the age of alchemy, from 300 to 1600 AD. What is alchemy? Alchemy is a science that focused on transforming base metals, such as lead, into gold, which was considered as the most perfect metal. Alchemists like Geber and others developed early chemical techniques that we know today, like distillation, crystallization, and sublimation. Breakthrough came for modern chemistry in 1661 when Robert Boyle challenged alchemy with his book, The Skeptical Chemist, laying the foundation for modern chemistry. Then the birth of modern chemistry, about 700 AD to 800 AD, the works of 4 scientists gave birth to modern chemistry. 1, Joseph Priestley in 1774 and Carl Scheele in 1772. They separately discovered oxygen. Carl Scheele discovered it first, but he didn't report it until some years later. But Joseph Priestley reported his own first. But these people performed experiments and discovered that there is a gas from air that can support combustion better than air. Number 2, we see Antoine Lavoisier. In 1789, he established the law of conservation of mass, a very important law in chemistry, which states that matter is neither created nor destroyed in a chemical reaction, but can only be transformed. And also, he redefined chemical elements. The 4th person there is John Dalton, who proposed famously in 1803 the atomic theory, explaining that matter is made up of indivisible atoms. Of course, that rose the curiosity of chemists to research more about these tiny particles. The 4th stage is the great leap for chemistry in 1800-1900 AD. That's the time we call the rise of modern chemistry, especially with the research of Friedrich Höller, synthesizing urea in 1828, giving rise to organic chemistry, disproving vitalism. What's vitalism? That was an age-old idea that organic compounds could only be produced by living beings and not synthesized from inorganic materials. But his synthesis of urea in 1828 disproved that. Then we see a great scientist called Dmitry Mendeleev, a Russian chemist. In 1869, he put together the periodic table from the various arrangements existing then. But because before his own arraignment, people like Johann Dobryna has a law of trials. He grouped elements into three based on their properties and atomic masses. There is also John Newland's law of octaves. He arranged elements by increasing atomic masses and found that every 8 element has similar properties, much like musical octaves. And Lothar Meyer's atomic volume curve. He plotted atomic volume versus atomic mass and has a curve similar to the table of Mendeleev. So Mendeleev built upon these ideas, but he went further by organizing elements into a table, predicting missing elements and their possible properties upon discovery, and adjusting atomic masses where necessary. During this 19th century, 1800 to 1900, significant advances were made in thermodynamics and electrochemistry also by several key scientists. There are many of them, but I will mention a few. In the field of thermodynamics, in 1824, Sadi Carnot, considered as the father of thermodynamics, introduced the Carnot cycle, explaining the theoretical efficiency of heat engines. Rudolf Clausius, in 1850, formulated the first and the second laws of thermodynamics and introduced the concept of entropy. What of William Thomson, a man we popularly called Lord Kelvin? He developed the absolute temperature scale, what you call Kelvin scale, and contributed to thermodynamic principles. What we use about Josiah Gibbs? He developed Gibbs free energy and phase rule, which is crucial for chemical thermodynamics. In the field of electrochemistry, Alessandro Volta in 1800 invented the voltaic pile, the first true battery, demonstrating how electricity could be generated chemically. The popular Michael Faraday established Faraday's laws of electrolysis, defining the relationship between electric charge and chemical reactions. What of John Daniell, who invented Daniell cell, an improved battery that provided a stable voltage? Svante Arrhenius, you cannot talk about electrochemistry without mentioning him. He proposed the Arrhenius theory of electrolytic dissociation, explaining how salt dissociates into ions in solution. Then the fifth stage is the 20th and 21st century, when we say 19 days and 20 days. This is the century of explosion of chemistry. 1. Quantum mechanics revolutionized chemistry. Can remember theories of Schrödinger wave equation, Heisenberg's uncertainty principle, and the postulates of Nebula about atomic structure and quantum mechanics. So the 20th century brought quantum mechanics, explaining how atoms truly behave. Chemistry also gave birth to polymers, plastics, and synthetic materials, pharmaceuticals, and materials that change the entire world. Lastly, we'll see now in the 21st century, fields like nanotechnology, artificial intelligence in chemistry, and green chemistry. All these fields are shaping the future. Even biochemistry is an offshoot of chemistry. The researches in these areas are shaping the future of chemistry as at this present time. From the fires of alchemy to the high-tech labs of today, chemistry has shaped our world in ways ancient alchemists could never have imagined. What's next? Maybe you will be part of the next great breakthrough. If you have enjoyed this journey through time, hit the like button and subscribe for more mind-blowing chemistry lessons. Thank you.